The last section, 7.1, we talked about the substitution method and how for that we needed to get either x or y or whatever variables we're working with. We needed to get that by itself so that we could see what it's equal to. Once we saw what it was equal to, we could take that and substitute in for that variable in another equation such that I was able to kind of get rid of one of the variables and solve for what's left. Well, here we're going to talk about the elimination method. The elimination method's another way to solve systems like we've been working with. And to do this, we're going to add and subtract entire equations in order to make it so I'm only dealing with one variable. Okay, how are we going to do that? Well, if I've got coefficients that are exactly the same, such as in this first example, I see 3x and 3x, that's great. If they're exactly the same, then I can go ahead and subtract those equations, and the x should subtract out. It should cancel out, leaving just y left to solve. If, however, I run into a problem where I don't have x is the same or y is the same, then I may need to do some, I guess we'll call it clever manipulation of those equations through multiplying in order to get those coefficients to be the same. We'll have examples of both, don't worry. All right, so let's take a look at this first example here. Number one, I've got these two equations. I've got 3x plus 2y equals 12. And in the second equation, I've got 3x minus 4y equals negative 6. Go ahead and write down this first example. Now, it may be helpful to label your equations. So if you want, you could label this equation A, label this equation B. Now, I see that looking over equation A and equation B, the coefficients on x are already exactly the same. I've got 3x here and I've got 3x here, which is great because I don't need to do any clever multiplication in order to manipulate these equations such that those coefficients match up. They already do match up. So I'm going to go and subtract equation B from equation A. Okay, since this is 3x and this is 3x, I can subtract these entire equations. Now when I do this, I'll get 3x minus 3x. Those are going to cancel. 2y minus negative 4y, careful with your negatives. I'm subtracting a negative here, so it's kind of like I'm adding. So this will end up being 6y, and this is equal to 12 minus negative 6. 12 minus negative 6, again, careful with your subtraction here. This will end up being 18. All right, 6y equals 18. Divide both sides by 6. To find that y equals 18 divided by 6 is 3. Which certainly seems like that's a lot easier than some of the things we were doing in the last section so far. And in fact, what we do from here is exactly what we did in one of the last sections, is we're going to take what we just found, y equals 3, and we'll just plug it into one of these equations. And it doesn't matter which one. So whichever one you think is going to be easier to work with, if you like equation A, you could just copy over equation A right here, 3x plus 2y, 12. And you could say y is now 3, so 3x plus 2 times 3, 12. 3x plus 6 equals 12. Subtract 6 from both sides. 3x equals 6. And finally, when I divide by 3, I'll get that x equals 2. Right, so let's talk about what we did. To start out, I saw that both of these equations that I was given, equation A and equation B, both had a coefficient of 3 for the x. This was 3x here and 3x here. In fact, I don't even care about anything else. I only care about the fact that they both have exactly 3x. And since they have the same thing, I'm able to subtract these equations because this will end up canceling that 3x. They'll subtract out. This left us with 6y equals 18. Solving for y by dividing by 6, I found y equals 3. Once I knew what one of the variables were, y equals 3, I could plug it into either of these equations. I plugged it into A, such that 3x plus 2 times 3 instead of y is equal to 12. And solving for x, I found x equals 2. And of course, just like the last section as well, if I want to confirm that this is the right answer, I could easily look at a graph or a graphing calculator, and I could plug these in. I could say 3x plus 2y equals 12, and 3x minus 4y equals negative 6, and they should intersect at exactly x equals 2 and y equals 3. Questions about that? All right, let's do one more. All right, so let's take another look at a problem like this with problem number 2 here. I've got negative 2x plus y equals 9, and 4x plus 3y equals 7. Go ahead and write this down. And again, I'm going to label these just so when I refer to these equations, there's no confusion. Let's call this first one equation A, and the second one equation B. All right, what do we immediately see that's different from problem 2, okay, in problem 2 than problem 1? You can either say out loud or you can type it in chat. Yeah, go ahead. Yeah, nothing's equal, right? So if I looked at the first one, let's go back. I had 3x and 3x, right? They were equal to each other, perfect. I was able to subtract, x dropped out. But here, nothing is the same. But what I do notice is that, for example, this is negative 2x, and this is 4x. I want the coefficient to be either exactly the same or exactly opposite. What I could do is multiply a by 2. So I'm gonna represent that by saying 2a over here. This is just saying everything in a multiplied by 2. So this would be negative 4x plus 2y equals 18. I am literally multiplying everything in equation A just by 2. And b I'm going to leave alone. B is still going to be 4x plus 3y equals 7. Okay, well, now, since they're exactly opposites, I can add these together. And you may be asking, why am I adding this time? In the first one, the signs were the same. Positive 3x, positive 3x. When I subtract, this will go to 0, meaning that the x will cancel. In this one, they're exactly opposites. Negative 4x and positive 4x. If the signs are the same, subtract. Same sign, subtract. Same sign, subtract. If they're opposite signs, add. So same sign, subtract. Opposites, add. Okay, when I add these together, x's will cancel. This will give me 5y equal to, and 18 plus 7, that is going to make 25. Divide both sides by 5. Y equals 25 divided by 5 is 5. Once you've solved one of the variables, just go back to your original equations here. Pick one of them, it doesn't matter which one, and plug in y equals 5. So I think, I guess the top one might be a little bit easier. So we'll plug it into equation A. This would be negative 2x plus y equals 9. Y is 5, so negative 2x plus 5 equals 9. Subtract 5 from both sides. Get negative 2x equals, that would be 4 left over here. Finally, divide by negative 2. So x equals negative 2. All right, any questions there? Okay, so what did we do here? I started with negative 2x plus y equals 9, 4x plus 3y equals 7. The x, okay, the coefficients on the x, these weren't the same. The coefficients on the y, these weren't the same. So I needed to do some kind of clever multiplication. I needed to manipulate one of the equations in such a way where the coefficients on either the x or the y, they matched exactly or they were exactly opposites. If they match exactly, meaning they're both in equation, or in problem 1, we had 3x and 3x, both positive. If they were the same sign, you subtract those equations. And here, they're exactly opposites. I had negative 4x and positive 4x. When they're exactly opposite, you're going to add the equations together. Doing so is going to make it so that coefficients, those coefficients on that variable, well, that variable is going to end up canceling. It'll subtract out, or in this case, add to 0. And then you're able to solve for the remaining variable. Here we solved y equals 5 and then plugged it into either equation. We just picked equation A to find that x equals negative 2. All right, let's take a look at number 3 then. For number 3, I'm given these two equations, 2x plus 3y equals -1, and 3x minus 5y equals 27. Again, first thing I notice without doing much else, the coefficients on the x's, not the same. The coefficients on the y's, not the same. So I'm going to have to do something. I'm going to have to do some clever multiplication in such a way where I can get either the coefficients on the x or the y to either match exactly the same or to be exact opposites. So I had a suggestion from someone in the room. What if I multiplied the first equation by 3 and the second equation by 2? That is exactly something that we could do here. So you're always trying to think of a way to get the coefficient, the number in front of either the x or the y, to be the same. So in this case, let's call this equation A and this equation B. What we could do is recognize that if I multiply equation A by 3, so I'll call this 3A, and equation B by 2, so we'll call that 2B, that should make it so that the coefficients on x are the same, just multiplying by each other. When I multiply equation A by 3, this will make this 6x plus 9y equals -3. Okay, and then multiplying everything in B by this 2, this will be 6x minus 10y equals 54. And now I see that the coefficient on the x is exactly the same, 6x and 6x. Since they're exactly the same, both positive, same sign, subtract. So I can subtract these equations. Six x minus 6x, that'll go to 0. Excellent, that's exactly what I want. 9y minus -10y. Again, careful with your negatives. So when I'm subtracting a negative, it'll actually be like adding. So this will be 19y equal to -3, and then minus 54 is going to be -57. Divide both sides by 19. And -57 divided by 19 is going to be -3. So y equals -3. Once you know one of the variables, go ahead and plug it into one of your original equations. So either equation A or equation B, doesn't matter. Here, I think equation A might be a little easier just because they're a little smaller numbers. So over here, we'll do equation A, which is 2x plus 3y equals -1. But now, y equals -3. So 2x plus 3 times y is -3 equals -1. 2x minus 9 equals -1. Add 9 to both sides. 2x equals 8. And then finally, divide by 2. X equals 8 divided by 2 is 4. Let's recap what we did here. I saw that the coefficients on the x and the coefficients on the y's, nothing really matched up. And there wasn't anything that I could multiply, say, 2 by to match 3, or there wasn't anything I could multiply this 3 by to match 5. So that meant that I'm going to have to do some clever multiplication where I multiply the first equation and the second equation, so equation A, by the coefficient from B. So I just picked x and I said, well, let's multiply A by 3. And then let's multiply B by 2. 3A and 2B. When I multiply through, I saw that both had 6x, which allowed me to subtract and solve for y. Then, just like all the others, once I solve for one, I plug it back into one of the original equations here to get the other. Now, could I have done something else? Yes. Instead of multiplying equation A by 3 and equation B by 2 to get the x's to match up, one of the things I could have done is multiplied equation A by 5 and equation B by 3. If I multiplied equation A by 5 and B by 3, then the y's would have been 15y and negative 15y. Those would have been exact opposites, allowing me to add the equations then, cancel the y, and solve for x first. So there's a number of different ways that you can actually do these problems. You're not set to doing them exactly one way. As well as there's, a whole bunch of other things that you could have multiplied by, but those probably aren't as efficient as just looking at what the coefficients of what the other equation has and multiplying by that. All right, let's pause here, and I'm going to ask you, if you're at home, type it something in the chat here, 1 through 5. If you're in the classroom, you can either type it in the chat or you can hold up a number of fingers. 1 through 5, 5 being like, I totally understand this. 1 is, I don't really get this at all. 3 is like somewhere in the middle, okay? Where are we at? I see a 5, I see some 5s, I see some 4s, some 3s, 4, 5, 4. Okay, excellent. Thank you very much. All right, let's try to finish. Let's try to do one more here, and then we'll take a short break. This one's going to have some bigger numbers in it. Go ahead and write this down. Okay, don't worry. They're just numbers, right? Seems like when it comes to numbers, people are either afraid of either very large numbers or very small numbers, like fractions or decimals. But regardless, whether you're working with really big numbers, really small numbers, numbers that you're comfortable with, just work on them in the same process that you have been, and you should get to an answer. All right, let's do this. Let's call this equation A, and this one equation B. Clearly, the coefficients on x, they don't match. They're not exact opposites. Same thing for y's. They don't match. They're not exact opposites. So what I can do here is let's try to get rid of the x's first. To get rid of the x's first, I'm going to multiply each equation by the other equation's coefficient for x. In other words, I am going to end up having 17a here. I'm going to multiply everything in equation A by 17 and 7b. Okay, go ahead and do that. It'll be 119x and negative 13 times 17 is going to be negative 221. So minus 221y. negative 416 times 17. This will be negative 7,000, negative 7,072. Make sure I did all my math right. 7 times 17, yep. Negative 13 times 17, and negative 416 times 17. All right, now the bottom. Multiply everything in B by 7. So 17 times 7, this had better be 119x, which it is. Okay, the reason it better be is because the whole point of this is to get these to match. All right, minus, let's see, that'll be 18 times 7 is going to be 126, so minus 126y. And finally, 576, so negative 576 times 7 is going to be negative 4,032. Subtract. Now that I've got the x's the same here, the coefficients. And again, these are large numbers, but that's okay. I'm just going to follow the process that we've been working with. Negative 221y minus negative 126. That's going to make negative 95y is equal to negative 7,072 minus negative 4,032 is negative 3,040. Divide both sides by negative 95. This is where you hope that you've done this correctly. If I divide negative 3,040 by 95, I do come up with an integer. All the answers that as we start things out, if I give you a problem with very large numbers, I will make sure that the answers are integers, so that way you know you've done it correctly. Then go back to one of these, plug in y equals negative 32. And find what x is. This here is going to be 416. Oh, convenient. Subtract. And divide. Oh, hold on a second. Oh, this is positive 32. Sorry about that. Positive 32. So this should be positive 32. And this will end up being all right, so when I do that, sorry about that, this will end up being negative 416. Seven x equals 0, so x equals 0. All right, let's take a short break because students in the classroom have a tornado drill. We will be back here in about 5 minutes. I'll see you then. Welcome back, everyone. For this last one, we got a little got a little confused here. I ended up dividing by negative 95, but forgetting that negative over a negative, this should have been a positive 32. So when we plugged in y equals 32, this ended up being negative 416 on both sides. So when I added 416, we got 0. So dividing by 0, x equals 0. Okay. We've got two more examples here, and then after that, we'll call it good for the notes, and the rest of the time will be time for us to work on the assignment. All right, for this one, I want you to try to do this yourselves. Try to come up with an answer. Once you have an answer, let me know by sending a private message with what you believe x equals this and y equals this, what you believe is the correct answer, and then I'll go through it and we'll compare some answers. So go ahead and do that. If you're catching this outside of regular class, pause the video here so you can work on this and then hit play again when you've finished. All right, hopefully that was enough time. Let's work on this. I'm going to call this equation A and the second one equation B. And what I notice is that the coefficient on A and the coefficient on B for both the x and the y, nothing matches currently. So what I need to do is multiply A by some number and multiply B by some other number so that I can get those coefficients to match up. The easiest way to do that is simply, well, if this is 3x and this is 1x, multiply by the other equation's coefficient. So let's multiply A by 1, so I'm not really doing anything in that case. A will stay the same. But then multiply equation B by 3. So I will end up multiplying this and saying this is a 3b. So that'll make 3x minus 15y equals negative 40 times 3. So that'll be negative 120. And now that they're exactly the same, positive 3x and positive 3x, I'm going to subtract these. Remember, same sign, subtract. Three x will cancel. Y minus negative 15y, careful with your negatives. So this will be 16y is equal to 136 minus negative 120. So that's going to be 256 because I'm subtracting a negative. All right, and then divide both sides by 16. Y is equal to 256 divided by 16 is 16. Lastly, plug y equals 16 into either of these equations to solve for x. Okay, so I think equation B has smaller numbers, therefore it might be a little bit easier. Let's plug that into equation B. X minus 5 times 16 is equal to negative 40. X minus, let's see, 5 times 16 is 80. So x minus 80, negative 40. And add 80 to both sides. So I get x equals positive 40. And again, don't be discouraged by larger numbers, or even if your answer isn't simply x equals 3, x equals 4, x equals 5 or something. If your answer is x equals 40, that might still mean that your answer is correct. Okay? There are a number of ways that you can check your answer, either by plugging in x and y to both of these, making sure that you get true statements, or graphing them and ensuring that your point of intersection between these two lines is going to be exactly 40, 16. All right, one more and we'll call it good. Number 6. Go ahead and write this down as our last example for today's notes. And same thing here, go ahead and take a couple minutes, try and solve this, figure out what you think is correct for x and y, send it to me in private chat. In a couple minutes, we'll work this out together and see if we come up with the same answers. Again, if you're at home catching this outside of regular class, go ahead and pause the video here so that you have time to work on this. Let's work on this together and see what my answers come up to be and see if they match up with yours. So I see that this is 10x plus 9y equals negative 174 and 2x plus y equals negative 54. And 10 happens to be something I can get to by multiplying this 2 by 5. So in this case, I am simply going to multiply b by 5, and I'll leave a alone. So a will be 10x plus 9y still equals negative 174. But I will end up multiplying everything in equation b by 5. So this will be 5b, and this is why labeling our equations is handy to see where we got these numbers from and what equation we're working with. This will be 10x plus 5y equals negative 54 times 5. That'll be negative 270. Same sign, positive 10x, positive 10x. So same sign, subtract. X's will cancel. 9y minus 5y, it will be 4y. And then negative 174 minus negative 270 is going to be a positive 96. Divide both sides by 4. Y equals 96. 96 divided by 4 is 24. Once I know that, plug this into either of my original equations. Again, the second one, b, looks to be a little bit easier just because the numbers are a little smaller. So let's do that. 2x plus y is 24 is equal to negative 54. Let's subtract 24 from both sides. Two x is equal to negative 78. And then finally, negative 78, we'll divide both sides by 2. X equals negative 39.